you should be able to see things. You should, things should go back and forth pretty nicely. So let's see if the first thing actually works. All right. So welcome to everybody. This is my breakout session. It's called Contracting for Calculus, incorporating technology projects into transfer level math courses. So I'm going to go through a little bit of history, kind of like what we did first, how we kind of got away from it, and then how I relaunched it, and I'm still doing it to this, this day. But before we do that, if you're missing Allerton, here are a couple pictures. Building, and I believe this is this Atlas Obscura, I believe, yes, kind of like that. And then of course the gardens. It's always so nice to go to Allerton this time of year. Everything's kind of leafing out, like to walk the grounds. So I really missed that part of the conference, along with seeing everybody else, but those are a couple of pictures. Okay, before we do this, I'm going to give you a little introduction of myself. My name is John Armon. I have been teaching at Illinois Central College since 1992, so I'm in my 29th year. I'm married. My wife teaches at Knox College. She's in her 30th year. We both teach math, and we have 2 kids. My oldest is in graduate school at the University of Southern California. He is studying math. He's in the PhD program. And for those who are interested, combinatorial representation theory is his field. Okay. And my daughter is a junior at McAllister College in St. Paul, Minnesota. And she is a geography major. And her emphasis is on public health. Pretty important nowadays. So I want to get a little bit of information from all of you. I'm also going to answer these questions, but think about how you would answer these questions. We'll kind of go around very quickly and give you a chance to answer as well. How many years have you attended IMACC? What do you like to teach? What have you taught the most? What's kind of your new favorite Zoom technique, since we're in the new age here? And of course, you need to answer what's your favorite baseball team. So I will go ahead and get started with that. And I'll just kind of go around you don't have to turn your camera on, but I would like to hear you. I'm guessing this is my 20th IMACC, if I remember correctly. My favorite class to teach actually was I don't really teach it much anymore, the math for elementary school teachers. There are projects we used to do in there, like teach them about the number systems and kind of the real life. Here's what it looks like for a particular society. I think we call it the Alphabetian Society. It's really, really cool. The class I've taught the most, college algebra. You'll see when we get to the demonstration part. I've taught pretty much every year. I'm not sure I have a favorite new technique in the pandemic era, but as long as I don't spend too much time in Zoom, I guess I'm okay. And favorite baseball team, it's Cubs, obviously. So let's go right around the top here. Amy, you want to go ahead and answer those questions?
So I've been at IMACC for, I think, 7 years, I think. I like teaching trig the most, just because I love that class and I love the puzzles. I have taught statistics the most. Last semester I taught it 4 times. So, and
I think Dawn can match you there, I think. 4 times.
And I don't know that I have a favorite teaching technique that's brand new, except that I do make my students do video presentations. So
that's good.
That's been kind of nice. Yeah. And plus then I actually get to hear them and see them, which is lovely.
Yes.
And what was and Cubs, absolutely Cubs.
I mean, is there another answer? We'll see. Riyati, go ahead.
This is actually my first IMACC.
Great. Great.
Um,
Welcome.
Thanks.
It'll be a little
And
different next year, I think.
yeah, not so zoomy.
Yeah.
What were the questions were what your favorite class?
Favorite class to teach, class taught most often, and then your new favorite technique, the Zoom technique.
So I do teach the Math for Elementary School Teachers sequence, and I've taught that. I don't know, I've taught most. I think I've taught that the most, but also trig and stats come in at a close second. Actually, I like having all three of them because then I get kind of a balance of different students. And I'm with you, Amy. I like trig and I like the puzzles too, but I also like Math for Elementary School Teachers because of the wonder and the number theory, and it's
Yeah, there's
fun
such a
time.
variety of topics you do in there. I like doing the ancient number systems and then just kind of other based number systems.
Yeah, you can incorporate a lot of history in it, so I enjoy that too.
Yes.
And then my favorite or my Zoom technique that works, I do a 3-2-1 self-assessment during class. Like one,
Yeah, I like that. I like that.
can you follow me? Or one, are you having, do you not know, necessarily not know what's going on? 2, can you follow me? And do it on your own. And then 3 is I'm test ready. And so students will, I'll ask them how they're doing on concepts, and then they give me all different, no negative numbers. So that was good.
No zeros, no negative numbers.
No, but then I address my ones and stuff. So it's nice to kind of clarify some things along the way. And then I don't watch baseball. Sorry.
Okay. I suppose no answer is as good as that other team. Oh, well, okay. Thanks. Yeah. Angie, go ahead.
All right. Hey, everybody. I know I've been a member of IMACC for 25 years. I've missed some conferences in there. Favorite class to teach would be between trigonometry and Calc 1. As far what I've taught most often, I'm just not sure. I've just been so all over the place. It'd be easier for me to kind of pull out the things that I definitely know I have not taught the most often. In the Zoom era, I have appreciated being able to meet individually with students over Zoom for either office hours or for outside appointments to help them individually. And that is something I think I'm going to take forward from this new era. And baseball, definitely the cards.
Oh, well.
I know.
Let's just remember who's won the World Series more recently. Okay, just remember that. Not more often, just more
recent. Yeah, operative word
exactly.
there.
Yeah. All right. Joanna, go ahead.
Me?
Yes, you. I know you.
I know you know me.
Yes.
So I've been at IMACC 5 or 6 years. My favorite class to teach, I think it's Calculus 3. I've taught college algebra the most. I don't know if I have a favorite Zoom technique, and I don't really watch baseball. Sorry.
Okay, that's no cancer. James, go ahead.
Yes, I've been at IMACC, I think, for 5 years. Favorite course? I'd have to agree with some of the other people, trig and stats. Maybe trig with top stats. I just like the fact maybe that the students are getting away from algebra courses that they've been taking for so long. Get some new material from a different perspective. Let's see, what have I taught the most? Basic algebra. Maybe another reason why I like trig so much.
Yeah.
And let's see, favorite Zoom. You know, I haven't done this yet, and I'm a little chicken to try, but breakout sessions in Zoom. We had a math trivia night when the pandemic first started, and somebody in our department tried it, and I said, wow, that was pretty slick. And I've seen it in conferences, but I'm just a little too chicken to try it. And then let's see, favorite baseball team. I'm gonna say Cubs from my childhood. So Ronsay, Sandberg area.
Definitely, yes.
Haven't been following baseball as much lately.
Yeah, I actually haven't either, but I know the Cubs are doing lousy this year. That's probably why. So thanks, James. Yelda, go ahead.
Okay, hello, can you hear me?
I can hear you, yes.
Yes, okay. Oh, sorry, I had a little bit of a difficulty there.
That's fine, that's fine.
I think it's my 5th or 6th year with IMACC, even though I have been around longer than that. I think with the course that I'm most excited in teaching is the staff with a lot of new data science improvements coming into it. I haven't taught that course, but I dabbled with it quite a bit, so that gets me really excited. Up to this semester, I think Calc was my more common course that I taught in various formats, but now Stat took over. In the Zoom, I like being able to actually do oral exams in Zoom that I wanted to do for years and years, and always have the contention of, did they say it this way or not? Now there's no contention. I record everything. Everything is like everything is discussed, and I get to have that fun discussion time that I want to do and explore. And no, I don't follow baseball. I apologize.
Yeah, basketball, baseball.
Sorry.
No,
Thank you.
Thank you. Kyle, go ahead.
Hi, everybody. I'm Kyle. I teach at Harper College. This is, I'm guessing here, but I think it's around my 9th year at IMACC, maybe 10th. My favorite class to teach is probably Calculus 2 at the moment. I probably taught stuff generally in the calculus sequence the most. That's where I spent a lot of my semesters. And in terms of baseball, I'm a fan of whatever is in the majority in terms of people in the room. So if most people in the room are Cubs fans, then I am a Cubs fan.
Well, so far, so good. We'll see. We'll see. All right, thanks, Kyle. Chalice, is it Chalice? Chalice?
It's Chalice.
Chalice, yes. Go ahead, Chalice.
So I think I went to my first IMACC conference in like 2006, maybe okay. 2007. I started my career then, but I was adjunct. And so I've really consistently been going since I became full-time about 9 years ago. Favorite class, I love teaching Calc 1, Calc 2. Probably most common class is either Calc 1 or statistics. I really like teaching both of those. One, I just like the Calc 1 students a whole lot. In statistics, we get to see a lot of, real world data, and it's just kind of fun for the students to see the application of, some real world data there. Zoom or new online learning things. I really like that some students who won't necessarily speak up in a physical class will at least participate in class in the chat. And so I really like that aspect.
It's a nice feature.
Yeah. And then of course the Cubs.
That is the right answer.
It has been a disappointing year.
If there was a right answer, yes. Thanks, Chalice. Dawn, nice to see you, Dawn. Dawn and I work in the same building, but we haven't seen each other in over a year, right? There she is. Hi, Dawn.
Hey. So let's see. I've been at ICC. This is wrapping up my 10th year, so this would be my 10th conference, except for the last one that didn't happen. So I've been to IMACC every year. As far as what I enjoy teaching the most, probably like our Math 110, like the liberal arts math requirement, just because I like that every unit is so different from the next one. So there's just a ton of variety. As far as what I've taught the most, the liberal arts math and the stats, I usually end up with 3 of one and 2 of the other, or, sometimes 4 and 1, it just depends. Let's see, as for baseball, I quit watching professional sports a long time ago. I'm a big college sports fan. But
favorite college baseball team?
There are college baseball teams.
Yeah.
But because my dad is a Cubs fan and my boyfriend is a Cardinal fan, I have to follow both of those teams so I can talk to those.
You can't follow both. I don't think that's allowed.
I don't really have a choice.
Okay. Thanks, Don. Lewis, go ahead.
Yeah, I'm Gary Lewis. I've been in
Gary, God.
Or like, no, that's fine. I should have put my first name. I'll have to fix that. I've been around for 3 or 4 years, teaching at Heartland Community College. I usually teach calculus, statistics, developmental math, and the elementary math courses, and some of the transitions courses that transition from developmental to 140, stats. Sorry.
Right.
It's hard to say which is my favorite course. I think it is the one that is easiest to create applications in at that moment, given our textbook. So that seems to be limited by me more than anything. What else was I supposed to answer? I forget.
Favorite new technique in the Zoom era?
Oh yeah, I love the breakout rooms like James. I use those to just get students chatting for a minute, and I can peek in and actually hear something they're saying for a change instead of me talking. So I love the breakout rooms. And of course, go Cubs go. Although thanks, Dawn, for bridging that gap and being Switzerland for us, but I got to root for my Cubs.
Agreed. Thanks, Guy. Is it Xiao Jing? Is that how you say your name?
Yes.
Yeah.
Hey, my name is Xiaoying, and I'm teaching right now in Wisconsin, Gateway Technical College, and this is the first time I joined the IMACC
Thank you.
conference. Yes.
Great.
Thank you.
Yeah.
Yeah, and then I teach all the way from pre-algebra to calculus 3. We just offer calculus 3 probably a year ago. Usually we offer up to calculus 2. So I taught all the way. In our college, we do not offer statistics. So my favorite class, I like teaching. So pretty much I enjoy every classes I'm teaching. But because I never teach statistics, and we just offer calculus 3, so I only teach it once. So I hope in the future I will have more chance to teach classes that I never teach before, or I can have more chance to teach it. So, because like calculus 3, I only teach it once. So if I teach one more time, I guess I can do better than the first time.
Well, the first time is always so much fun. Yeah.
Yeah, but overall, I love teaching. So I think I enjoy every class. So I'm not a sports fan, but if I had to pick one, I grew up with basketball because in the hometown I grew up with, we have basketball games like every once in a while. But my son is a soccer game. My son plays soccer. So right now I kind of like watch soccer games more often. So that's it.
Okay.
Yeah, I don't know much about baseball. Thank you.
That's
my
okay.
experience. Yeah.
Well, thanks everybody for sharing their information. So let's go ahead and actually do some presenting here. So I wanted to give you a little bit of history behind this idea of technology projects. As I said, I began teaching in the fall of 1992. It was about the time graphing calculators were being introduced. You might remember the good old TI, it wasn't the 84s yet, I think it was the 81s. They were talking about using computer algebra systems like Maple and Mathematica were being introduced. And so me as a curious person was thinking, how can we use these more in a problem-solving context? So I got together with a few of our faculty members. Actually, when I started, there was one of our faculty was on sabbatical at U of I. He was learning about Mathematica. So he came back and wanted to really get going with this idea. So he joined up with 4 relatively new faculty with this alliance that we were going to incorporate this technology into the problem-solving process. Have that be part of the grade. Everybody would contribute problems. And the good news is it was supported by our chair. That doesn't always happen. You have this new idea, and then somebody up here says, I don't think we're going to do this. But our chair did support it, which was good. We were getting problems from various sources, different textbooks. I had been at an MAA conference 1 year earlier. I don't know if anyone is familiar with, it's called the Ithaca College materials. It was like, almost like active calculus, got some ideas from there. And it was nice, there were 5 of us. It was myself, Chuck Wright was the elder faculty member. Some of you might know Pat Ward. He was hired a year after I was. And then Robin and Mary Beth were the other 2. And of those 5, there's 2 of us left. Pat's still there. The others have moved on to other places. So part of this new assessment, we were thinking, let's have meetings, presentations, not just with your own students, but with other students in these other classes. So everybody would be teaching a section of the calculus class. You would sign up for one of these technology projects, but whoever wrote the project would listen to the presentation. So not only your students, but students from these other classes. So it's almost like we had this huge class of calculus students. We met at the end of the term as a group to assign the grades. So we'll talk more about the grading later. So write-up and presentation was all part of the syllabus. And we called it contracting for calculus because it was kind of the idea, you know exactly what you need to do to get a particular grade. You had to do this and this, put those together, there's your grade. So we were doing that for the fall of 95. We continued it in the spring of 96. We stuck with Calculus 1. And then Pat and Robin and Mary Beth and I all presented a paper about our idea at the, I couldn't remember the official name, it was some type of technology conference that summer in Baltimore. And then the big one was the ICTCM conference in Reno that fall, the International Conference of Teaching of Collegiate Mathematics, if I remember the acronym correctly. So that was really, really cool to get out there and show our stuff. So we did this for about 3 years. And then I don't know exactly what happened, but some of us moved on to what we would refer to as reform calculus, if you're familiar with the Hughes Hallett material. In fact, Robin and I went to another conference out west to learn about that. I still did projects. I just didn't call them calculus technology projects. So I kind of graded them the usual way. After doing that for a few years, in response to students' reactions to the projects and then how they were performing on the projects, I decided, hey, let's revisit this idea of the technology projects. So this was actually fall of 2005. Unfortunately, oops, didn't mean to do that. Unfortunately, I did not have any takers to collaborate with me. So it was just me. I was teaching Calculus 2 that fall. So I started in Calculus 2 and I moved to 1 and then to 3. Got the new syllabus and the grading rubric, which we'll talk about when I show the examples. Doing them for the first time and then continuing to do them, I kind of made a little list of what I thought the benefits are of doing it this way. Students were able to collaborate. They could talk to each other about problem solving. They had, of course, turn in their own work and still do the presentation part. I had more contact with the students. Students had to present, as I said, at a conference. And the obvious, hopefully obvious, was the increase in their technology skills. They can use new and different technologies, so not just a graphing calculator, not just a computer algebra system. Their writing skills, I think, also improved because you had to write it up, just like a report. Communication skills improved. And the other thing I really liked is I never really told them how to do them. I just said, you know, solve this problem. There was a variety of different types of solutions. So I think those are all definitely benefits of doing this. Still working on some things. Not sure students are always turning in their own work, so, but even though when you do that presentation, you kind of talk about it, you get kind of an idea, do they really know, do they don't, do they not know it? I find it hard to get the projects all to be about the same length. So if you look at some of the examples, you might say, oh, some of these seem kind of lengthy and some of them are much shorter. I'm trying to get them all to be about the same length. This is a big one. Misunderstandings about how projects are used to compute the grade. I'll show you the syllabus. I'll show you what they're supposed to do on the write-ups. Maybe you can tell me where the confusion is, because I think it's pretty clear. I just got a message today from a student saying, you mean I don't need to do 5 of these? I only need to do 3? It's like, yes. Did you read the syllabus? Okay. So because there's a 2-component part of the grade, the written work and then the projects, some of them are not doing enough projects to get the grade they want. And then this is always, you know, we're always at kind of a very high work stress level. Is this really worth the benefits to the student? That's kind of an open question for me. So I think it's worth it. Maybe as we go through more and more, it's going to be less worth it, but I think it is something that definitely benefits the students. All right, so here's what I'd like to do is kind of show you some of these technology projects. This is just kind of a timeline. So the Calculus 2, second semester I started in 2005. I started with doing 10 projects. We currently do 6. And these are the semesters I've actually taught Calc 2. Last 2 summers ago was the last time I taught Calc 2. Calc 1 started the next fall or spring, I can't remember. Also with 10 projects, I currently do 8 in there. And you can say I've taught Calculus 1 a few more times, currently teaching Calculus 1. And I didn't start teaching Calculus 3 until about 2016. So that was a little bit later. But this was the term we had to go switch online halfway through the term. So I'm going to show you some examples of some of these projects from Calculus. I'll give you kind of the old and the new, and then show you some examples of student work. So I have this in order, so let's hope it works. Okay. So you're going to let me know if you can see something or hear something. I'm sure you will speak up, right? This is a part of the Calculus 1 syllabus. So here's what it says. These are the percentages for each of the components. Here's what you need to do to get an A. You have to do 90% or better and complete 4 technology projects. Not 80% or better, 3, 70% or better for the 2. So this is the calculus class that has the 8. So their breakdowns are 4, 3, 2, and 1. So they have to do 1 to get at least a D, along with that the percentage on the written components. So that's what it looks like in the syllabus. At the end of the syllabus, there is an explanation of how to write them up. So real world applications, good buzzwords here, inside creativity. Technology is the key here, trying to use technology in the solution process. One of the things we were trying to do in the beginning was to get them to use new technologies. So it was the graphing calculator, it was Mathematica was kind of new at that time. Now it's more graphing calculators are old technology. Computer algebra systems, the ones you have to pay for, that's old technology. So now we got things like Desmos, we got GeoGebra, other examples of students that have found apps online that'll do things. So that's one of the benefits about doing this is I learn about new technologies. If students show me something, you can do an Excel spreadsheet, things like that. So here is what they need to do when they think they have a solution. They write it out, show all the details, charts, graphs, all there. This is, you can see this is a current syllabus. They have to save it as a PDF or Word. And then this is what will happen when they turn it in. If everything looks good, no revisions are necessary, I put a P at the top. I say you have passed this project, nothing else needs to be done, put 1 in the pass column. Usually what happens is result number 2. The revise, if I want them to change something, if they didn't include a graph or an explanation, or maybe the ordering was a little off, I'd ask them to revise it. So they revise it, they send it back to me, I take a look at it, and we have this back and forth until essentially I'm happy with it. And that was one of the things I wanted to do when I went back to these projects is sometimes when you're grading projects, it's a certain number of points per part, and then they get their score, everything is fine. This is more of a, you can kind of think of the first one as not a rough draft, but the draft they think looks good. And if something doesn't look good, they get a chance to revise it. So there are no numbers here. It's just you turn it in, it looks good, I give them a pass. If it doesn't look good, I tell them what they need to change. And then unfortunately, I had to add this third category because there were some students who decided, oh, this is just like a homework problem. He'll let us rewrite them. So they scribbled something down without a whole lot of knowledge of what's going on with the problem. In this category right here, they are not allowed to revise them. So I call it N, not accepted. And I tell them that, and I tell them why. And it's not going to, unless it's the last one, it's not going to be a huge problem. They can just try another one. And then I try to help them feel better by saying, don't expect your work to be accepted the first time. So in calculus, I give them 8 problems overall. Most of the other classes, I'm down to 6. They're just given at equal times throughout the semester. As you'll see when we look at some of these examples, just over the different topics. So calculus, got your limits, continuity, derivatives, and some antiderivatives. So here's an example. This is one of the first ones I did when we did a reboot. 223 is calculus 2. I sometimes gave them cute names. E6, nice baseball reference there. So here's an example of using trapezoid, midpoint rule, Simpson's rule, where they're expected to do the calculations not by hand, but using some type of technology. And then do the integrals, do some upper bounds. If you've taught Calc 2, a fourth derivative upper bound is pretty hard to do by hand. So technology is the key there. And just being able to answer these questions about their work. Here's another one from Calc 2. Can't argue with the title, right? What goes up must come down. So this is more along the lines of differential equations. You can see velocity equation, time for the ball to reach its maximum height. So they were expected to use some technology in the problem solving process here. Here's another one I do from Calc 2. I think it's pronounced Bezier curves. Those are those computer-aided designs where you put a bunch of line segments together to form a curve. You can do it with parametric equations. So this is pretty nice. And some of the graphs I got in these are really, really neat. Okay, so here are some current Math 223s. Maybe you've done this problem before. The pictures are kind of missing here, so I apologize for that. Picture a circle divided into 3 equal parts, but not the usual way with horizontal or vertical cuts. Where do you make the cuts so that everybody's got the same amount of pizza? So that's a problem I do now. Here's my E6 again. Some other definite integral applications. You probably remember the density problems. Some of the volume questions are in here. Here's one with a system of differential equations that has to do with the Lotka-Volterra equations. So they're actually, they're supposed to be graphing it, use some type of computer algebra system there. So those are all examples from Calc 2. So Calc 1, this is what I currently do, trying to investigate whether 0 to the power of 0 should have a limit. Here's one with the linear and quadratic approximations, kind of leading up to the Taylor polynomials, which are done in Calc 2. And then one just looking at a comparison of a bunch of different graphs changing a constant, where they can just do the part of the graphing on some type of technology, and then by graphing 10 of these, you can then make some assumptions there. Here's some from Calc 3. So your topics in Calc 3, vector, curves, and curvature. This is a different example of a what goes up must come down question. I really like this one because I'm a baseball person. Longest home run, think about those trajectories. They talk about how far would it have traveled if it wouldn't have hit this thing. They had to investigate that as part of, you know, parametric equations there. And this is one of my favorite. Designing a soda can, you've probably done this example before, with maximum volume or maximum surface area, and talk about why most cans on the shelf aren't of that particular type, but doing it as a Calc 3 question. And then because they have the capability of actually seeing these graphs in 3 dimensions now, you can do an investigation on limits and actually talk about approaching 0, 0 from a bunch of different paths, which is really hard to do, as you know, algebraically. Okay, so just show you a couple of quick examples of some student work here. This is the newest version of the limit question. What should 0 to the power of 0 be equal to? So here is a good example of that. So the student did their numerical data. They did their graph, and they said, hey, those two numbers are the same. They really zoomed in on the graph here, so that's really nice. And then they're supposed to investigate these 3 functions right here. Once again, numerical data, lots of numerical data. And then the graphs, I did include some comments here as to what I wanted them to change, like use a larger scale. And then they had to come up with their conclusion. So there's their conclusion. So this person wrote it up and actually typed everything up. The next example I wanted to show you was someone who just kind of wrote things out the usual way, but everything is there. They're investigating this limit. There's numerical data. There's the picture of a piecewise defined function. Okay, so I'll get to that when we get to the end. So thanks for asking the question there. So just showing you a couple different types of problems that the students, or not problems, but the types of work they turn in. So they could type it, they could write it. And this person actually wrote things very neatly. So investigating continuity questions, for example. This is one of my favorites. I like this one. They had to figure out why this was a straight line, even though it's representing daylight hours in Madrid. And the answer, of course, was it's straight because you're zooming in on that part of the graph. That's why the function is differentiable. Then they had to fit a trigonometric curve to it because it is periodic. And then they had to investigate this question about how many hours of daylight you get on June 21st, which is the summer solstice. So if you look at everywhere else in the world, it kind of goes up to a particular point, but when you're in the Arctic Circle, it's flat, it's 24. So this function they had to work with and get that output and then decide where the function was differentiable or not. So these are not ones that are easy to graph by hand. So here is a student who had to do a rewrite. And I wrote on there, you know, what kinds of things I wanted them to change. And this is, my writing is not very good, but I was able to write on my tablet. So they were able to make the changes, and you can see the difference between the R and the P there. And one of the nice things about doing it this way is they can submit them, upload them, and then I can write on them and send them back to the student, and they're able to get them changed pretty easily. But here is their graph. Got their hours there, and there's a graph. And you look at that point and you say, of course it's not differentiable there, but the function, when you see it algebraically, you're not really sure about that. When you see the graph, it's pretty clear. This is a current student who did the exact same thing, but notice that they wrote it up by hand, which is perfectly fine. All right. Let's go back to slideshow here. Because I know I promised you some other classes. So here's what I currently have in other classes. College algebra, finite math, business calculus, college trigonometry. I know a lot of you said you like to teach trigonometry. Pre-calculus. I also did differential equations. I haven't taught that very many times, but I was able to implement it in fall of 2019. Future work, concepts of math, that's our gen ed, I guess we call it gen ed math. We call it math 110. Gen ed stats, and then linear algebra. I'm currently teaching linear algebra. I did not have enough time to get projects ready for that. I will say that even though I don't call them technology projects, I'm teaching a section of concepts of math right now. I know people are talking about how they like the different units. And each unit I have right now as a project related to it. So I don't call them technology projects in there, I just call them projects, but that's a projects-based class. So I'm not sure I'm going to turn those into technology projects, but I do have a whole set of projects for all the different units that we teach. So we do linear and exponential growth, finance math, graph theory, probability. So those are some of the units we talk about in there. So I want to show you a couple of things from college algebra here. So here's the syllabus for college algebra. Pretty much looks the same. The only difference is the numbers are lower because college algebra for us is a 4-hour class. So it's 3 for the A, 2 for B, 1 for C. Okay, now I don't need to explain to you, you're all math people, right? Of course, students are taking it. What does and mean? Both must happen in order for this to be true. You can't just get 90% or better without the second part. So both have to be true at the same time. So that's one of the problems I've had explaining this to students or who they say, oh, what if I do 4 or 5 of these? Would it help my grade? It's like, no, 3 will help your grade. 4 or 5 will not help your grade. So there's no reason to do more than that. Okay, let's skip over this part here. So here are a couple of the current Math 115 projects. So one-to-one, composition, inverse functions. They had to look at a graph to determine if a function is one-to-one. They had to take the graph of something and find the inverse and then graph those two on the same screen. Here's one with linear function models. A lot of the college algebra examples could probably be used in stats as well. This is just essentially a line fitting the data. And you can see this is relevant data. CO2 levels going up. You've probably seen this example before. Temperature and chirps per minute for crickets. Good biological example there. So they pretty much have to use the regression feature on their calculator or whatever technology they're using, and then fit a line to it. So this student used Excel. These are Excel graphs, and they look really good. They look really good. I just had her change one thing here because she wrote, I don't know how she got that year, but she went ahead and changed it, and I got a P at the top because she actually changed it to the right number. So there's an example of how Excel is used. I'll also do one with quadratic functions. So fitting a quadratic function to data that goes up and then goes back down. This student here, he's one of my current students. He's very detailed. I mean, look at this work here. It's not just that. He's got the graphs. There's the linear function. There's the cubic function. There's the regression equation. So it's all there as part of what he turned in. And then I asked him some questions about the graphs. This was like a 20-page representation here, but you can kind of see it all there. So just giving the students the variety in the problem solving process. Some are good, some are not as good. This is one I do later in the term. This is one of the systems of equations and matrices. The student kind of pasted in some pictures of his calculator. So hey, I can see an intersection point here, looking good. Setting it up as a matrix. What does the RREF of the matrix look like? So you can see all that that he did there. I did have him change this because he unfortunately didn't have the right equation for the second part. But when he changed it, there it is. This is the changed version, and these are now the correct answers. And then doing with exponential function models, this is one where you have the number of monthly active Facebook users going up. And then you have the opposite of that. What happens to your car when you drive it off the lot? It goes down. So they have to fit a model to both of those situations right there. So those are some examples. I guess we don't really have enough time to show all of these, but those are the problems currently I use, and then the examples from the students. So like I said, I'm in process of expanding this to other classes. So I want to make sure there's enough time at the end for questions, and I'll get to the chat here in a minute. But if you kind of want to think about these questions, if anybody has something they would like to add, you can just kind of chime in. Who among you uses projects as some type of assessment tool? What are the technology options at your institution? How do these projects kind of fit in with what you might call standards-based grading? And then if you have any other questions for me. So let me get to the chat question here real fast, because I'm sorry, Shalise, for I'm not trying to ignore you here, but answering what Shalise is asking, it depends on the students in terms of the rewrite. I've had back and forth like 6 different times. It's like, just read what I wrote there, change it, and then there's usually a deadline when I ask them to do that, but usually 1 or 2 rewrites is enough. And I do worry about them being shared. Anyone familiar with Chegg knows that some of your stuff ends up there. And I've noticed a couple of my projects ending up on there. I've also noticed that ones who answer on Chegg aren't always answering them correctly. But I know what it looks like. And I do ask them to take them down at the end of the term. So I do worry about that, especially in this day and age. So something to watch out for. I did make a couple of rewrites for this coming term, so I will know whether they're using old information. So that's something. And as far as the technology options, I pretty much let them do what they want. If they want to use graphing calculator, that's the nice thing, is there are more and more things that they're showing me. I had not seen an Excel graph before this term, even though Excel's been around how long now? Desmos is now a very popular one. That one student I was showing you with the real long details, I forget what type of technology he uses, but he told me one time, and I thought it looked very, very interesting. If they want advice from me, I can give them advice because I'm pretty well versed in the calculator, and I'm not as well versed on things like Desmos or some of the newer ones. So if we were in class, I would have the students actually say, oh, here's what I use, this works really well, and then students can pick up on that. So how do you all feel about projects in general? Projects, yes. I know a lot of you said you taught stats, so that seems to be a good fit. Good fit. Anyone want to say anything about projects?
Yeah, I teach a computer science course also, and it's nearly all projects and quizzes. So one of the issues that I run into is that students will drag out a project for way too long. Do you have a cap on how many times they can submit or a length of time?
I don't have a cap on how many times they could submit. There's like a 2 to 3 week window where they have to turn them in. So like every 2 or 3 weeks. I want to make sure that part is, once that original deadline is passed, they can't initially turn it in. But as far as the rewrites, I've actually been kind of lax or lazy. I had to send out a message to my online college algebra class saying, hey, you still haven't rewritten that first project. But there really should be more structure there. Because if you drag it out for too long, they're going to forget.
Yeah.
And they don't read their email anyway, right? So.
Right. I have another question.
Go ahead, James.
Do you often have students that have a I don't know how to say this, paper grade of, without the projects, a high grade, but they're reluctant to turn in enough quizzes to get the actual grade that they think they're earning? That's
that whole, going back to what it says on the syllabus, where it says you have to get 90% or better and an A. I quizzed them on the first day about, well, maybe the second day, about reading the syllabus. And I said, okay, you got a 95%, you've done one project, what's your grade? Half of them say A, half of them say C. And to me, it's like, why are you saying A? 90% or better and this number of technology projects, you fit this category, 70% or better and 1. So there is some confusion there. And I've had to send out messages this term as well, kind of explaining, not the necessarily that, but the number that you're doing, trying to tell them this is another part of your grade. It's not extra credit. You don't do these for extra credit. You do these as getting a part of your grade. You're contracting and saying, I want to get an A, so I'm going to do this and this.
Thank you.
And that's one of the things I'm still working on, because you as math people, you understand the word and. They're supposed to understand the word and, but I sometimes think they throw in the word or instead of and.
Don, have you considered putting it in a table? And so say that they have to do one in this column and that column, so they can see it more visually?
That might work better, the visual learners. I might try that. Okay. Any other, anybody got any new technologies that have been kind of, that you've seen from your students or at your institutions? Like I said, Desmos has just kind of taken off for a lot of my students. I know we started doing it a little bit more last fall, I think it was, or at least for me. I had not seen it a whole lot before. Mostly probably because it's free. Got it like that. Mathematica costs money. Maple costs money. I'm all for free apps. I don't think I've paid for anything on my phone.
We're considering starting a data science program. So
nice.
This sounds like it would be up that alley. And so the free software and tools that be available there are R, and then for plotting and for working.
Yeah, R. That's funny.
Yeah,
that's funny.
And then Tableau for data visualization, and also Python. Those would probably be the most common.
Okay, those sound good. I know we've talked about Desmos and GeoGebra are the two that we've at ICC have talked about amongst the faculty members. I don't have a lot of experience with GeoGebra though. I don't really have a lot of experience with Excel either, but it's mostly graphing calculators for me. I even have my old-fashioned Inspire. Look at that screen. Any other questions for me? Anything else? I did want to just kind of show you this last slide. If anybody wants any more, I can send you a whole bunch of projects if you want. I got, as you saw, all those classes. I have projects available for them. Just send me a message. That's my email. And thanks a lot for coming. I had a good time sharing some information with you. I don't want to go past.
I'm sorry, can you put your email address again?
I'll do that, yeah. I don't want to go past 4 since I heard the business meeting went too long. So it's just essentially, it's my first initial, last name, and then icc.edu. ICC.
Thank you
Thank you.
very
You're
much.
very welcome.
We currently use Maple. We have a Maple site license, and I've just
Oh, nice, nice.
well, yeah, I've been looking to upgrade though to something a little more current. So
We used to have a Mathematica, this was way back in the day, and we were one of the first departments on campus. that
تو
had computer
شلفو
lab.
خورما روشه بغل دست چیزه. Oh, I'm sorry.
Yeah, so we had
I thought I laughed.
so we had a site license for Mathematica, and we had a computer lab in our math lab, but not enough people, I think, used it. So
yeah, and we currently offer like graphing calculator workshops every semester.
Right.
And I think if I wanted to do something like this, we might need to also offer some other workshops. Or do you find that students kind of figure it out themselves?
some of them do, but I think there are many students who could benefit from it. Thanks, Jordan. Because I know when we're actually in person, we actually do talk more about in class of how the calculator is used, because this is the easiest thing to do. You can carry it around with you, and you don't need a big laptop or anything like that, or any license to visit something else. So
Sure.
so
Great. Well, thank you very
all
much.
right, thank you all. Have a good rest of your day.
Thank you.
Thanks.